Video, we're going to be talking about this activity. How do you interpret the relative ages of rock layers? So this isn't trying to find out the precise age. This is trying to figure out the approximate age just based on other things. So comparing things. So you might look at homes or something like that, and you can say, well, this house looks older than that house. And why would you say that? Maybe one is more beat up, or the style is older, or whatever, and one has nicer paint and is like has a more modern look. You could compare the age, like, and compare relative age is just really a comparison. So here is your sample that you're going to be looking at for this activity. So the first question says, identify a type of unconformity between any two layers of rock. Give the reason why you think it's an unconformity. Just going back to the material, remember an unconformity, like here's an example of a disconformity. That is where there was hard rock here and it should be flat because of lateral continuity, but it is not flat. It got eroded away. So that's an unconformity. Another unconformity that you might see is angular unconformity, or nonconformity, where there's a hard rock layer covered by a sedimentary layer. Okay, so those are some choices to answer number 1. So do you see any evidence of erosion or angular unconformity? Okay, the next question is, interpret which rock layer is the oldest. Well, we talked about the law of superposition, where the older layers of something are always going to be on the bottom, unless sometimes you have something like an intrusion. So I have a picture here that I want to show you. It might be here. So here, normally, you're not sure if D or this like red layer here, this gray intrusion, or the red layer is older. Well, the red layer is going to be older because the intrusion cut through it afterward. So the layer of rock is always older than the intrusion that cut through it. And if you're unsure on that, go back and watch some of my earlier videos where we talk about that. The next question is, infer are when something has cut across, oh, I'm sorry, I keep going to the wrong page, like this, and it has grabbed up other debris along the way. So it's included other rocks into it. So here, I would say for sure D would have some inclusions in it. The next one is compare and contrast the rock layers on the left and the right side. Why do they not match? Okay. And sometimes you have, I'm still going to the wrong page. Sometimes you have the left and right side not matching. For instance, here, you don't have the left and the right side matching because there was obviously some kind of fault or mountain building activity that came along and caused this to break. And because of that, they no longer match on each side. The next question says, which feature, the dike or the folded strata, which is younger? And what geologic principle would you use? So, so which one is younger? This area here that got buckled, or the intrusion here? So we've talked about that a few times, so I want you to go back and listen. I think I kind of already said it in this video, but in the other videos, to tell which one of those would be older or younger, and then name the principle that goes along with it. This is in section 2 of your book. It might be section 1. No, it's in section 2. Okay. The next question is, propose why there's no layer E on this side. So here's E, okay? So E is here, and there was some kind of fault here, and they used to match up. So all of these used to match all the way down, and then something came and pushed up. Why is there no E here, right here? It picks up back again here. But what happened here? Excuse me, just remember that sometimes there's disconformities and understand why that happens. So that's how you complete this activity here. And please turn it in on Canvas.